Anyone who believes in indefinite growth on a physically finite planet is either mad or an economist.
We don't want to focus politics on a notion that involves the rejection of principles around which a large majority of our fellow citizens organize their lives.
We are not as endlessly manipulable and as predictable as you would think.
I suppose I was driven to do this because of the idea that I've been covering this world of manufacturing probably for about 15 years. And in that time, I've had the opportunity, because of working for the Financial Times, that I've been able to travel around the world, go to about 30 countries, probably talk to about 5,000 manufacturers in that time, making just about every conceivable thing, really. But it's all about something very simple, really. In the world, you've got to start with materials. Materials are derived from the chemical elements, as chemists know. There are 180 chemical elements. Only 100 of them are available easily. So you've got 100 things which you can either dig up from the ground or you can grow, I suppose, or you can get animals to give them to you, milk or hides, etc. And then it's up to you. Then you put in energy and you put in ideas and you have 10 billion products, which are the things that we all use to make our lives easier and entertain us and everything else about that drives modern life. It accounts, if you look at the statistics, 15-20% of the world GDP, which again is quite sizable. In Britain it's a lot less than that. It's probably 10-12%, depending on how you measure it. But worldwide, it's a big chunk of what's going on. It employs 300 million people. Quite a small part of the world population, maybe 5% of the world population, probably 10% of the notional workforce of the world. But they do an awful lot. Productivity is pretty high. Hence, a small number of people can do a lot. And you can see that since 1800, which is when manufacturing in the modern way really began in the world, manufacturing output's gone up by about 200 times on a kind of inflation-adjusted basis, and world GDP has gone up about 60 times. So you can see it has been the driving force of the world. Things have leveled out a bit in the past 30, 40 years, but when the first industrial revolution was just kicking in, Britain's role in this was really quite small. There was only 35 countries in the world, you could say then, of any importance, if you kind of look at the literature, and Britain was in number 5 position. China was the number 1, actually, in manufacturing output. Britain was quite a small player in terms of population, as it is today, but accounted for a reasonable amount, 4.3% of world manufacturing output. China, actually, was the biggest by a long way, with about 30%, India a bit behind. It was during the 19th century that things really got going, and Britain was the country to seize upon those ideas, to automate a lot of production which had previously been done by hand, textiles, metallurgy, and so on. And therefore, it meant that it could punch above its weight. Its population in 1900 was still quite low, although by then it's 2% of world population, but it was producing 15% of world manufacturing output. And as you can see, the manufacturing position, it was actually number 1 out of 57 countries in the world. By 1900, America was the biggest. Britain was no longer the biggest. China was actually hardly anywhere by then, because China and India had a terrible 19th century, essentially. If you look at the figures today, well, you could say it's not bad, really. Number 9 position out of a world that's got much more complicated, many more countries in it, and now it's become a specialist player. I mean, I've just put this man in his mattress factory, because not many people probably know that if we think about things that Britain does, where it's quite good at, it is very good at making high-quality mattresses. So this is a little kind of potted history, I suppose, and this is another depiction of it. This is the way what I'm calling rich countries and poor countries have divided up manufacturing output between them. You can see that the red line is the percentage for what I'm calling the rich countries, which are the kind of obvious ones, Western Europe, Japan, America. The blue line is essentially everyone else, and they're the inverse of each other, clearly. In 1800, China, India, which I'm calling poor, for want of a better word of describing them, because these things obviously shift. In 1800, Belgium was a developing country, essentially, and China was a developed country. But then, of course, the story of the last 10 years, as you can see from the blue line going up and the red line going down, is that China, India, other so-called low-cost countries have been coming back into the game. But it's only kind of replicating where they were before. So obviously there's been an awful lot of things going on, but we're kind of back to where we were 150 years ago in some ways. And if you want to be really simple about it, you can boil it all down to that one chart. In fact, you can say the whole of world history for 3,500 years can be encapsulated in this way. Pre-industry, which was the start of the Iron Age, essentially, in around 1500 BC, somebody invented a way of getting iron ore and turning it into iron. And even though iron ore is very abundant in the Earth's crust, it was always terribly hard to find a way of getting the iron from it, for all reasons to do with chemistry and physics. Proto-industry is what I'm saying really happened next, or the key place was the Venice Arsenal. This was the shipyard where they brought in standardized parts production, essentially, and that set the tone for much of what I'm saying is the proto-industrial age. Before the first industrial revolution came in, people gradually learnt how to do things making standardized parts, from ship components to bits of guns and so on. The first industrial revolution then followed. There's a picture of the James Watt steam engine there. And then I'll just skate through these other things because, in a way, this is all things that we know about already. The third one is the way that science came together, gave you electricity for one thing, gave you cheap ways of making steel, which previously hadn't really existed. The fourth industrial revolution was, again, the period that most of us are familiar with reading about what happened in electronics and computers during World War II and after that, which again gave a big boost to the world economy. What I'm trying to say now is that we're on the cusp of another new age, which I have called the fifth industrial revolution. It's not something driven by just one thing, it's a number of things, and these are the seven components of it, the ways of combining biotechnology and electronics, for example, to make all kinds of new medical machines that will either monitor what you're doing in your daily lives or when you're in hospital. The second thing is customized manufacturing. Of course, there's been a lot of discussion just recently about 3D printing, which is the technique for building up parts on a layer-by-layer basis using these great machines. But there's an awful lot of other techniques to customize manufacturing where people are just learning better how to make goods efficiently and relatively cost-effectively. Rather than making thousands of them at a time, they can make them more or less on a one-off basis. A lot of this is about digitizing the manufacturing process, but it's also a lot about just having got better at doing this over decades or centuries. 3D printing should be considered as just one kind of weapon in the complete armory of how to do customized manufacturing. The niche approach, I suppose, is this idea of saying that nowadays the number of opportunities for people to specialize in a very narrow area has become much greater than before. They can base their operations just in one country, perhaps. They can spread themselves out around the world in terms of having production operations sometimes scattered wildly. They can use the internet to sell what they're doing. The global manufacturing pathways is a way of saying you do have the ability to link up now much more than you did in the past. And so therefore it becomes much more possible than it did for a little company in Britain to perhaps have some other operations in China or Malaysia or elsewhere where they do things in concert with them. A lot of the intellectual property development may still take place in Britain, or it could take place the other way around. It could take place in China or Malaysia, have some of the production taking place in Britain. You've got more possibilities. The environmental responsiveness in the past, people used to make things pretty much without much regard for the environmental consequences. Now people have woken up to that. there's many examples now of companies who are using environmental awareness as a way of selling their products. Wave power manufacturers, for example, which is a kind of interesting new industry where Britain, again, has got a good position. It's just one example, but another nice example is Strix, the world's biggest maker of kettle thermostats based in the Isle of Man. It's using its ideas to reduce the amount of electricity that kettles use and therefore fit into this environmental responsiveness. China opening up is clearly one part of the whole thing. China's obviously got a lot going for it, but it's got a lot of things going against it as well, even though obviously there's an awful lot of things going on where they've let Western companies in. A lot of the Western companies feel they can't do what they want to there. Equally, there's Chinese companies getting better at what they're doing, becoming better at innovation and technology, and doing things around the world. But there's no reason to think that China is necessarily going to take over the world, as some people think, either in manufacturing or anything else. Clusters are all about groups of people in one country doing things together, doing things sometimes in a collaborative basis. At the same time, they're bound into these global supply chains. Sometimes people think, well, you can't have both, but indeed you can. And some of the best examples of the most successful manufacturers today are people who are part of a small cluster of people, of companies, whether it's in Leeds, making medical equipment, which is a reasonable group of people, or in Sheffield, where they still do a lot of metals-related engineering. They can be linking up at the same time with people around the world who are sometimes making their products for them, sometimes selling them. So obviously I could give you lots of examples about each of those areas where Britain plays a role, but I just thought I'd end with one, really. This is made by Germany. This is a small drilling machine, which I don't suppose many of you have heard of, but if you didn't have these drilling machines, you wouldn't have printed circuit boards of the kind we use today. Printed circuit boards being the things that hold electronic parts that are going to just about everything with any electronics in them. You need these drilling machines which drill tiny holes in the printed circuit boards, so the printed circuit boards work effectively, and so you can cram in as many electronic circuits on these boards as you want to in today's smartphones and so on. Schmoll is one of the companies who make the drilling machines, and there's two companies in Britain, both based in Poole in Dorset, who make the things that are required to make those drilling machines work properly, which are called air bearings. And in fact, I have an air bearing spindle. That's an air bearing spindle here. And this is something that essentially whirs round at a terrific speed, might be 300,000 revolutions per minute. I think it's about 100 times faster than a jet engine. And it's also capable of drilling very fine holes. The kind of wobble or the lateral displacement is very low. There's three companies really in Poole, in Dorset who make these things. They again link up around the world. And I learned, by going to China, I learned that the people who make this little bit of copper, which goes on the outside, which you can't really see, but if you didn't have that tiny layer of copper, it wouldn't work. So I said to these people in China who were part of this company, where'd you get that from? And after a bit of discussion, they said, oh, we're somebody in Britain. And eventually I found out where it was, and it's some little place in just outside Chester. And because you couldn't think of a less obvious place to see a kind of hotbed of manufacturing. So I went there to see them. They just about let me in. And it's a little place run by a woman and her father who are putting these coatings on in a little factory on the edge of a field with horses in it. So it's those kind of unobvious things that are going on. I could spend another hour talking to you about other people doing things like that in the UK. Britain's got a lot going for it. I mean, it's certainly not going to just kind of do what it did in the 19th century, but it's with the right kind of understanding, the right kind of certain amount of guidance and understanding and support from government policymakers, it actually could do quite well. Thank you.